Hello learners, and welcome to today's lesson of sigma notation and series. Let's look at what we are going to be looking at in today's lesson. So we are going to be talking about the arithmetic series, the geometric series, and of course the sigma notation. So by the end of this lesson, we will address the sum of arithmetic sequences, the sum of geometric sequences, and the sum of infinite geometric sequences that are convergent. And then we are also going to look at series presented in sigma notation. So we know the keywords that we are supposed to be using, or the ones that we are used to when working with sigma and series. Let's look at the content errors or the misconceptions that usually occurs, so the common ones. The learners do not know how to choose the correct formula. So choosing the correct formula is very important. Learners do not know how to interpret word problems. So that's also very important. And lastly, learners do not know how to interpret a series presented in sigma notation. So those are the common errors. And hopefully by the end of this lesson, we will be able to clarify those misconceptions. Let's not forget, of course, the skills that we need when it comes to us writing that exam paper. Let's now look at what you should know and be able to do from grade 10 and 11. You should know that the sum of numbers means to add those numbers up. And of course, from grade 12, we should know that the sigma notation means the sum of a given series. And the sum of an arithmetic sequence and a geometric sequence can be calculated by the given formulas. So those formulas are provided to us. And lastly, a sigma notation needs to be expanded. So we need to expand that sigma notation before we can work with it. Let's quickly go to an ad break and then we'll see you just now. Welcome back from the ad break, and let's continue with our lesson. We are going to move over to that first concept in our concept map, and that is the arithmetic series. So looking at the content and skill problems, learners calculate the common difference but end up using the formula that has a common ratio. So it's very important that you do not make this mistake. If you calculate the common difference, you need to use a formula that has the common difference. And in the exam, learners do not use the formula sheet correctly. So you need to take those formulas exactly as they appear on the formula sheet. Let's look at some key theory aspects when it comes to the arithmetic series. The general term of an arithmetic sequence is Tn is equals to A plus n minus 1, that's n minus 1, and that is multiplied by d. And the general term of the sum of an arithmetic sequence, again, that is Sn, n divided by 2, and in a bracket 2a plus, and in a bracket it will be n minus 1, and that is multiplied by our d. So that is what you're supposed to know when you're working with an arithmetic series. Let's look at an example. It says there, determine the sum of the first 20 terms of the series. So we have been given there a series 3 plus 7 plus 11 plus 15. Of course, we know that for us to calculate the sum of these terms, we need to firstly choose the correct formula and then substitute the correct values. So we know that we should determine whether we are working with an arithmetic series or a geometric series. So we can see there that the difference between those two numbers is 4. And how do we get that 4? We said 7 minus 3. And when we move over, 11 minus 7, that is also a 4. And again, 15 minus 11, that is also a 4. So that is a common difference. And we know this because we found it by saying T2 minus T1, and it gave us the same value as it did when we said T3 minus T2. So we know that when it comes to formulas, we will be working with n divided by 2, and that will be multiplied by a 2a plus n minus 1 multiplied by a d. That is the formula for an arithmetic series. We are calculating the sum of the first 20 terms as we were given, and as you can see, we have substituted the value of n, so that will be 20 divided by 2. The first term there is a 3, and the difference as we've calculated is the 4. And of course, using your calculator, the sum of those 20 terms is going to be 820. And that is our answer there. Let's look at a second example. The second example there says the sum of the series 5, 3, 1, and that series of course continues, is 216, or rather a negative 216. Determine the number of terms in the series. Well, firstly, we are calculating the value of n. So that's what we need to find there. But before we can do that, we need to find what kind of series this is. And we can see that from 5 to 3, we subtracted 2. But again, from 3 to 1, we subtracted 2. As we can see, that is a common difference, which means we need to choose a formula that has a common difference in it. Now, how do we choose whether we use Tn or Sn? Well, if we look at the information, we have been given the sum of this series. So we are being told that negative 216 is Sn. It is the sum of these terms. So that's the one that we are going to use. So that is Sn is equals to n divided by 2. Then we open that bracket, that's 2a plus n minus 1, close, multiplied by d, and then we close that bracket. We are just going to substitute those values in there. N is what we are looking for, so that is not going to be substituted. Then we have 2, and that 2 is multiplied by the first term, in this case is 5, plus n minus 1, and that is going to be multiplied by a negative 2. Of course, to make things easier for ourselves, we're going to work within that big bracket there, and that is going to be 10 minus a 2n plus a 2. And when we simplify that further, we are going to have there in that bracket, we have a negative 2n plus 12. And of course, when we multiply, so we can see that we do have a fraction. So what we can do is to multiply throughout that fraction. Well, firstly, we can we can multiply by 2 throughout that fraction. That's going to give us a negative 432 on this side. And on this side, we are going to have an n, and that is going to be open bracket negative 2n plus 12. And of course, we can just multiply that n in. In fact, when we do multiply that n into the bracket, that is just going to give us a negative 2n squared plus a 12n. And when we take all the terms to one side, that gives us a trinomial that's going to be a negative 2n squared, or it gives us a quadratic equation. That's a negative 2n squared plus a 12n plus 432. We can, of course, simplify this by dividing by negative 2 throughout, which is going to give us an n squared minus 6n, and that's going to be minus a 216. So this is a quadratic equation. Of course, you can factorize it the way you are used to factorizing a quadratic. You can factorize it the way you are used to factorizing a quadratic, but in the factors that we are going to have here is n minus 18, and we also have an n plus 12. That gives us two values for n. N is equals to a positive 18 or n is equals to a negative 12. And of course, we know that when it comes to our values of n or our term numbers, we need to choose that positive value of n. Therefore, n cannot be the negative 12, but it is that 18. And that is when it comes to arithmetic series. Let's go over to the next concept in our concept map, and that is the geometric series. So now, looking at the content and skill problems there, learners calculate the common ratio but end up using the formula for the common difference. So again, if you are going to calculate the common ratio, you need to use a formula that has the common ratio in it. And when it comes to the exam, learners do not use the formula sheet correctly. Make sure you get those formulas exactly as they appear on the formula sheet. Now, looking at the key theory aspects here is that the general term of a geometric sequence is Tn is equals to a multiplied by r exponent n minus 1. And when it comes to the general term of the sum of this geometric sequences, we know we have two of them when r is smaller than 1 or when r is greater than 1. The formula sheet does provide only one of these formulas, so when it comes to the problem at hand, just use the formula that is provided on the formula sheet, regardless of what the value of r is. So there we have those general formulas. So let us see or an example of this. The first example there says determine 3 plus 6 plus 12 plus 24 plus, and the series continues to 10 terms. So we need to calculate the sum of these 10 terms, but before we can calculate, we need to find out, do we have a common ratio or a common difference? Let's find out. So from 3 to 6, we can see that it was multiplied by 2. And again, from 6 to 12, it was multiplied by 2. You can easily find these values by either saying T2 minus T1, or if that doesn't work out, it would be T2 divided by T1. That's how you find out that it is a common ratio instead of a common difference. So we already know that this is a geometric series. So we are going to choose a formula that will help us to calculate that. So the formula for a geometric series, that is going to be A, and then we are going to have here open bracket, that's r exponent n minus 1, and that is divided by r minus 1. So we are going to just substitute. How many terms are we calculating? We were told that to 10 terms, so meaning we were given the value of that n. The first term there is 3. We've seen that the ratio is a 2, so that is 2 exponent 10 minus 1. And that is going to be divided by 2 minus 1, and of course the sum for 10 terms, when you put that into your calculator, that is going to be 3,069. Let's move over to the second example when it comes to the geometric series. So we have been given the series 3 open bracket 2x minus 3, and that bracket has been squared, plus 3 open bracket 2x minus 3, and that bracket has been cubed, plus 3 open bracket 2x minus 3, and that bracket has an exponent of 4. It says therefore which values of x will the series converge? Now our key word there is converge, because when it comes to converging series, then we must know that the value of r is between -1 and 1. Now most of the time learners get this inequality incorrect, but it is on the formula sheet. Please go and look for it. It is there and it will always be there. Whenever you see the word converge or convergent or converging, we know that our R must be between -1 and 1. Go write this inequality as it appears on the formula sheet. What else does this tell us? Well, it tells us that we need the value of R, because that statement has R in it. So we need to go and find the value of R. Remember, we were not told whether this series is geometric or arithmetic, but because we know that we are working with convergent and we know that we are working with this inequality that has an R, then we automatically know that this is a geometric series. So R is T2 divided by T1. That is going to give us that 3 bracket 2x minus 3, and that is cubed. That is divided by 3, that same bracket, but in the first term, it is squared and not cubed. So that is going to give us, if you divide that correctly, a 2x minus 3. And that is the value of our common ratio. So we are going to take that common ratio and we are going to substitute it in the place of R. That's 2x minus 3. And when we solve for x, then we know that that 3 is going to go on both sides of our inequality. So that is going to be 2x. And on the right-hand side, we're going to have a 1 plus 3. Remember, it must change signs. And negative 1 plus 3. So on both sides, it's going to be that plus 3. Then, of course, we know we are going to divide by 2. So that is going to be that 2x divided by 2. On this side, we have a 4 divided by 2. And on the left side, we have a 2 divided by 2. That means that the value of x is going to be between 1 and 2. That is what the value of x is going to be. So it's going to be somewhere between the value of 1 and 2. And remember, looking at our common ratio, we know that we cannot get a ratio of 0. So we know that if we had to multiply our 2 by 3 over 2, that would give us a ratio of 0. So that's something that's like an extra thought that you have to put into it, because we know that the value of x is going to be between 1 and 2, and we know that 3 over 2 is between those two values. We can then say there that x can be any value between 1 and 2, but really it cannot be 3 over 2. So x cannot be 3 over 2. That's just an extra thought to put into our calculation. Let's quickly go to an ad break and then we'll see you just now. Welcome back from the ad break, and let's continue with our lesson. So now we are going to move on to that sigma notation. Let's get to it. Now, when it comes to the content and skill problems with the sigma notation, is that learners do not understand that expanding the sigma notation allows us to know which type of sequence it is so that the sum can be calculated. Now remember, sigma is just a symbol that is used to represent sum of. So whenever we have a question that has sigma, it means we must calculate the sum of. But we do know that we have the sum of an arithmetic and the sum of a geometric series. So we need to decide which series it's going to be. But the only way we can do that is by expanding that sigma notation. And when it comes to the exams, again, learners do not expand the sigma notation. You need to understand how important it is to expand that sigma notation. Now, let's look at the key aspects that you would have learned in previous grades and your current grade. Well, the first thing to do with a sigma notation is to expand. That is the first thing you need to do. The expanded series will inform whether it is an arithmetic or a geometric series. The number at the bottom of the sigma the number at the bottom of the sigma notation indicates to us where to start when substituting. And then the number at the top of the sigma indicates to us where to stop when we are substituting. Now, the number of terms are calculated by using the numbers at the top and the bottom of the sigma. So for the number of terms, we do use that formula. I'm sure you're very familiar with it. Top minus bottom plus 1. Let's look at this first example. So it says they evaluate. So if this kind of question confuses you and you're not sure what to do, remember what sigma means. Sigma means sum of. So when it is written they evaluate, it means you need to calculate the sum of. What is the first thing that we need to do? Well, we need to know whether we are calculating the sum of an arithmetic sequence or the sum of a geometric sequence. So we need to expand our sigma. Let's substitute those values. Remember, the first value that we are going to substitute is going to be the 4. So for us to get that first term, the first term is going to be where we say 2 multiplied by 4 minus 4, and of course that is going to give us a 4. So 2 multiplied by 4 is 8 minus 4, that's going to give us a 4. Term 2 is going to be 2 multiplied by 5. Remember, we are going to move according to the number line. So because we started at 4, we need to continue with the next number. So that is going to be 2 multiplied by 5, which is 10, and when we subtract 4, then we are going to get 6. And when it comes to that third term, that is going to be 2 multiplied by 6, which is the next number after 5. And then we are going to subtract 4. So 2 multiplied by 6 is 12 minus 4. That's going to give us 8. So what does our series look like? Well, it is 4 plus 6 plus 8. And this is how we represent it, because we know that we are working with a series, we are working with sum of, so you need to indicate that we are adding. Then when it comes to the formula, that is the sum of. How many terms are we calculating here? Remember, the number of terms can be calculated by saying the top number minus the bottom number, and we are going to add 1. In this case, top minus bottom, that's going to be 70 minus 4, which gives us 66. And when we add 1, it's going to be 67. So we are calculating the sum of 67 terms. Now remember, the formula for SN for an arithmetic is going to be, so we've decided that this is an arithmetic, because it has a common difference. From 4 to 6, we add 2. From 6 to 8, we add 2. So let's start by writing out that formula for the sum of an arithmetic. That is, of course, n divided by 2, and that is 2a plus n minus 1, and that is multiplied by d. Remember to take this formula exactly from the formula sheet. So that is going to be 67, since as well we know the number of terms is 67. So 67 divided by 2, and we're going to substitute all those values. The first term is 4. The number of terms is 67. We are going to subtract 1, and our common difference there is a 2. And we are going to now close off that bracket. So the sum of the 67 terms there, when you put that onto your calculator, that is going to be 4,690. So it means that we've evaluated the sigma notation, and the sum of these terms is 4,690. The next question there says, a convergent geometric series consisting of only positive numbers has the first term as a constant ratio of r, and the nth term, Tn, such that a sigma notation there, which represents the sum of infinity, and that sum of infinity is equals to 1/4. So the first sub-question there says, if T1 plus T2 is equals to 2, then write down an expression of A in terms of R. So we know that T1 plus T2, that we can just simply write it down as is, but we also do know that the first term is A, as given there in our statement. So if we have T1 plus T2 is equals to 2, that means A plus. And how do we move from A to the next term? Well, we do know that this is a geometric series, which means that for us to get to the second term, we do multiply by r. So if we multiply by r here, our second term is going to be A multiplied by r. So that is what we are going to substitute in the place of r. And that, of course, is equals to 2. Now we are asked to find A in terms of r. So we can take out a common factor there. That is going to leave us with 1 plus r, that is equals to 2. And when we divide by 1 plus r on both sides, that is going to leave us with a is equals to 2 divided by 1 plus r. And that is the answer for our a in terms of r. Let's look at more questions, more sub-questions within this question. Well, it says there that calculate the value of a and r. Now let's look at what we had been given. We were given a sigma notation where we were told that when n starts at 3 and ends at infinity, then the answer is going to be that 1 over 4. So we already know that the sum of infinity is 1 divided by 4, or 1/4. Then we also did calculate that a in terms of r was 2 divided by 1 minus r, and of course we know that when it comes to the sum of infinity, the formula there is going to be a divided by 1 minus r. So we need to take all this information and put it together so that we can find the values of a and r. So let's start with the sum of infinity. Now, if you remember, this sigma notation that we were presented with, it started at 3. So we know that from 3 right up until infinity, we know that our answer will be 1 over 4. But when we are looking at the whole sequence as a whole, we know that there was a start at 1 and there was a start at 2, which is the first term and the second term. So that would have been that T1 and that T2, because them being added is part of the sum of infinity. So that T1, that first term, plus that second term, plus the whole sigma that we have been given, which would be now starting from that 3 right up until to that infinity. So the sum of all of those numbers from 3 right up until infinity. So again, we've got that first term, we've got the second term, and we've got every other term from 3 going right up until infinity. So that is the sum of that whole series. Now, when we substitute, we know that to calculate the sum of infinity, we have 1 divided by 1 minus r. And we know that in the given information, term 1 plus term 2 was equals to 2. And we also know from the given information that that sigma of the terms that go up until infinity, the ones that start at 3, that is going to be equals to 1/4, because that is part of the information that was given to us. So that information that was given to us, n is equals to 3 there. We know that when it goes up until infinity, that will be equals to that 1/4. So this is us just including all the terms of this sequence or of this series that we have been given here. So we have the first term, the second term, and we have the sigma notation to represent from us substituting the value of 3, which is the third term, right up until infinity. Then we need to calculate here. So as we can see, 2 plus 1/4, that is going to give us 9/4. And on this side, we have a divided by 1 minus r. Now, remember, from the previous sub-question, we had found a in terms of r, and that was 2 divided by 1 plus r. It was actually a 1 plus r. So us having calculated that, it means we can now substitute it in this equation. So to avoid having a fraction divided by a fraction, because that just opens up opportunity for errors, this is the same as a multiplied by 1 over 1 minus r, just before we substitute that value of a. So now this means that in the place of a, we can just say 2 divided by 1 plus r, and that is multiplied by 1 divided by 1 minus r, and that is equals to 9 divided by 4. So how are we going to multiply that? That means we are going to multiply these two fractions together. And remember, when we are multiplying fractions, numerator is multiplied by the numerator and denominator is going to be multiplied by the denominator. So this is going to be 2 multiplied by 1, which is 2. And that's going to be divided by, when we multiply 1 plus r with 1 minus r, that might remind you of a difference between two squares, but that is going to be 1 minus r squared, and that is going to be equals to 9 divided by 4. So when we continue with that, remember, when we have fractions, the best way to get rid of them is to multiply by the denominators. So on one side, we're going to multiply by 1 minus r squared, and on the other side, we're going to multiply by 4. So that is going to be 8 is equals to 9 that is multiplied by 1 minus r squared, and that's what we have there. So remember, we are trying to get to the r, so we are going to divide by 9 both sides. That's going to be 8 divided by 9, and on this side, we simply have a 1 minus an r squared. We are going to take the 1 to the other side, and that is going to be our 8 divided by 9 minus 1, while on this side, we have a negative r squared. Now, you will see that if we calculate 8 divided by 9 minus 1, that is going to give us a negative 1 divided by 9. And on this side, a negative r squared. We divide both sides or multiply both sides by a negative 1. That's going to give us 1 over 9, and that is equals to an r squared. Now, when we put a square root on both, not forgetting our plus minus, that means our r is going to be, now it is going to be a plus minus 1 over 3, but remember, in the initial statement we were told that this sequence only consists of positive values. So for it to only consist of positive values, we need to multiply by a positive ratio. So that means that we are going to choose an r value that is equals to a positive 1 over 3. What about the value of a, actually? So we've already calculated r. What about the value of a? Well, the value of a, we can just simply substitute. Remember, a is equals to 2 divided by 1 plus r. And in the place of r, because we have already calculated it, we can just substitute there. And that answer is going to be a 3 over 2, or 3 halves. Let's quickly go to an ad break, and then we'll see you just now. Welcome back from the ad break, and let's continue with our question. So the next question there says, given the quadratic number pattern, -3, 6, 27, and 60, determine the general term of the pattern in the form Tn is equals to an squared plus bn plus c. Now, remember, this is a quadratic pattern, so we've been told that it's a quadratic pattern, and what we know about a quadratic pattern is that it has a second difference, and there is a method of calculating that value of a, b, and c. So when looking at the pattern, that is there a -3, then we have a 6, then we have a 27, and then we have a 60. Now, the difference between them, 6 minus -3, that is going to give us a positive 9. 27 minus 6 is going to give us 21. And 60 minus 27 is going to give us a 33. Of course, we know there is a second difference involved, and that second difference is 12. Now, what do we know about calculating the general term of a quadratic pattern? Well, we know that 2a is equals to the second difference. We know that 3a plus b is equals to the second term minus the first term. And we know that a plus b plus c is equals to that first term. So let's go ahead and calculate them. So 2a is equals to 12. If we divide both sides by 2, that means a is equals to 6. Then we have 3a plus b. Of course, we're just going to substitute that a. And when we add b, that should be equals to the 9. Then 3 times 6 is going to be 18. That means that b is going to be equals to a -9. And then lastly, we have C. Remember, C is A plus B plus C, which is equals to the first term. So we can just write those values in. That is going to be our 6 plus our negative 9, which means we are going to subtract that 9 plus our C, and that is going to be equals to the first term, which is our negative 3. Now, when we simplify that, we will see that C will be equals to 0. So that means that our Tn is equals to an squared, and our a is 6, plus bn squared, our b is a negative 9, plus c, and our c is a 0. So that means that that is our general term. Let's go to the next sub-question of this question 3. Now, it says there that show that the sum of the first n terms, show that the sum of the first n first differences of the pattern can be given by Sn is equals to 6n squared plus 3n. So when it comes to a quadratic number pattern, you know that you have never calculated the sum of a quadratic number pattern, but you do know how to calculate the sum of an arithmetic number pattern, and that is the pattern that is given by the first differences. So it is very important for us to read the statement. So the statement there says the sum of the first n first differences. So which pattern are we actually focusing on? We are focusing on that pattern there, and that is 9, 21, and 33. And of course, we know that this pattern forms an arithmetic pattern. So we need to show that the first n terms of that first differences, that is equals to Sn is equals to 6n squared plus 3n. Remember that we need to show that this formula is true, which means that we cannot use this formula when calculating. So that is Sn is equals to n divided by 2. Then in the bracket we have 2a plus n minus 1, and that is multiplied by d. Let's substitute what we have. Well, in this case, looking at this first differences, our a is 9 and our d is 12. Our n will just be n because we are looking for the first n terms of this first difference. So that means it's going to be Sn is equals to n divided by 2, and in the bracket we have 2 multiplied by 9, n minus 1, and the difference is 12. When we are simplifying that bracket over there, we are going to have 2 multiplied by 9 is 18. That is plus 12n minus 12. And of course, we are going to multiply by 2 throughout the, or we don't actually have to do that. We can keep it as Sn, but when we simplify that bracket there, that is going to be the 18 minus the 12. So the 18 minus the 12 there. So we still have n over 2, and we have 12n. And that is 18 minus 12, the 18 minus 12, not 2, that is going to be a positive 6. And we have that there. So what is left for us to do? Well, we need to now multiply that n divided by 2 throughout. So we are going to actually multiply the numerators, or we're going to multiply the n, and we're going to divide the 2. So that is going to give us an answer of, well, when we multiply n over 2 by 12n, that's going to give us 6n squared, because that 12 is going to be divided by 2 and the n is going to multiply with the n. Then again, we're going to do the same thing with the 6, and that is going to be plus a 3n. Okay, so that's Sn is equals to 6n squared plus 3n. And when we look at what we were required to show or prove, it is exactly that answer. Let's move over to the next question. It says there, without using a calculator, determine the value of, and we have been given two sums that are presented in sigma notation. That's what the first thing you need to realize there, that it's two sums that are presented in sigma notation, and we need to substitute these values, or we need to find the sum of each sigma notation separately, and then after that we can subtract them from each other. So let's start with the first one here. So we know that we are going to start substituting our y values at 3, and we are going to stop at 10. So that's not a lot of values to substitute. The term that we were given, or the general term that we were given, is 1 divided by 1 minus 2. So it says without using a calculator, so we need to do this manually. So we are going to find those terms. So the first one there, if we substitute 3 in the place of y, that's going to be 1 divided by 1. So that is going to give us 1. And then when we now substitute 4 in the place of y, the next one there is going to be 1 over 2. And when we substitute moving forward, the next one is going to be 1 over 3. Remember where you are going to stop, you're going to stop at 10. So here we've substituted our 3, here we've substituted our 4, here we've substituted our 5. And when we move forward, then that is what the expansion of the sigma notation is going to give you. It's 1 over 6, 1 over 7, and lastly, plus 1 over 8. So from substituting 3, 4, 5, 6, 7, 8, 9, and 10, that is the sequence that we get. Now we're going to do the same thing with the next one, but that sigma, we also start at 3, we stop at 10, but it has a different general term, which is y minus 1. Now when we substitute these values here, we can see that it is going to be 1 over 2 when we substitute the 3, then 1 over 3, 1 over 4, 1 over 5, 1 over 6, 1 over 7, 1 over 8, and lastly 1 over 9. Now remember why we're expanding it from the beginning to the end, because we were asked to not use a calculator, meaning we're not going to use those formulas. So what is happening here? We are going to subtract one sequence from the other sequence. But what you can notice there is that this sequence consists of the same numbers except for only 2 values. So if we were to subtract these values, then we know that this half would minus this half, a third would minus a third, a quarter would minus a quarter, a fifth and a fifth, a sixth and a sixth, seventh and a seventh, an eighth and an eighth. So they would subtract each other there because they are exactly the same. Then what would we be actually left with here? We would be left with a 1, and that would be minus the 1/9. And of course, 1 minus 1/9, the answer there is going to be 8 over 9. And that's how we can solve that without the use of a calculator. Let's quickly go to an ad break, and then we'll see you just now. Welcome back from the ad break, and let's continue with our lesson. Let us wrap up this wonderful lesson that we have had on the sigma notation and a series. So we did look at those arithmetic series and the geometric series, and also those sigma notations. Then, of course, not forgetting the words that we regularly use when we are working with the sum of, or when we are working with sigma notation. Now, when it comes to the content errors or the misconceptions, now we know that the learners do not know how to choose the correct formula. Please be careful of that. When you have calculated a common ratio, use a formula that has an R. And when you've calculated a common difference, use a formula that has a D. And of course, when you're asked to calculate the sum of, make sure you use the correct formula. Learners do not know how to interpret word problems, so make sure you read those sentences carefully, making sure you pick up every detail that has been given to us in that statement. And again, learners do not know how to interpret a series presented in sigma notation. Remember, when you are presented with a sigma notation, sigma means you are calculating the sum of. And for you to calculate the sum of, you need to determine whether it's an arithmetic or a geometric series. And the only way you can do that is to expand the sigma notation. Get those first 3 terms so you can see if we are working with a common ratio or a common difference. Let's not forget those skills that we are going to need in the exam. Make sure that you keep on improving these skills when you are practicing. And lastly, we know that the only way to get better in mathematics is through practice. So here are additional questions that you can use to practice when it comes to those sigma notations and those series. Thank you for watching this wonderful lesson. I hope you enjoyed it as much as I did. See you next time. Goodbye.